Welcome to the Bowery, a jazz club as famous for its predilection with bow ties as it is for its sinister figures. Today, with their help, we will be talking all about the regulation and actions of thyroid hormones. Thyroid hormones are synthesized and released by the thyroid, a small bow like gland that sits directly in front of the trachea. Because of this, the thyroid is symbolized here by this dapper singer's bow tie. This stage is also bow shaped to help you remember this. The thyroid gland is made up of two types of cells that allow it to carry out its two major functions. The first of these are the follicular cells, which produce the thyroid hormones that set the metabolic rate, our primary focus today. This is represented here by our singer's fabulous mullet, which was grown by some equally fabulous hair follicles. The other types of cells are parafollicular, or C cells, hence our singer's seashell belt. These cells produce the hormone calcitonin, which promotes calcium homeostasis and will be covered in more depth in another sketch. Assisting the thyroid with this are the four small parathyroid glands. These produce the aptly named parathyroid hormone and are involved in monitoring and regulating serum calcium and phosphate. These glands sit in each corner of the thyroid's posterior surface, which is why they are represented by the polka dots on this backup singer's bow tie and the lights in the corners of the stage. Like calcitonin, this will be covered in more depth in another dedicated sketch. With that out of the way, let's take a closer look at the hypothalamic pituitary thyroid axis and its regulation of thyroid hormones. Starting at the top is the hypothalamus, which secretes thyrotropin-releasing hormone, TRH, and is represented by this stacked TV playing a hyposize ad. TRH, in turn, stimulates the anterior pituitary to produce and secrete thyroid-stimulating hormone, TSH. This bartender's hair bow is sitting just below the pituitary punching bag in this lower TV to help show this. It is this TSH that then stimulates the thyroid gland to make and secrete the thyroid hormones T4 and, to a lesser extent, T3, depicted here by these T4 and T3 time bombs. TSH also exhibits a trophic effect on the thyroid, meaning it stimulates thyroid growth. Because of this, chronic levels of TSH or TSH-like substances will result in thyroid hypertrophy, which we'll talk about more in another sketch. Some unique things about thyroid hormones are that they act on virtually all organ systems, and the more active form is primarily produced outside the thyroid gland. This is because most T3 is actually converted from T4 in the peripheral tissues, and is 3 to 4 times more potent than T4. If you take a look at this sinister fella sitting peripheral to the bar, you'll see he has started the countdown on his T3 bombs, but not his T4 bombs, to show this. Before we jump into the nitty-gritty of what the thyroid hormones actually do, you should know that this entire process is regulated by a negative feedback system. Specifically, T3 and T4, but mostly T3, will inhibit TSH secretion by downregulating TRH receptors on the anterior pituitary. It is this system that allows for a relatively steady rate of thyroid hormone secretion. You can see this depicted by this worker who is reacting to the T3 and T4 bombs under the bar. You'll note she is trying to pull down the bartender with a hair bow, our symbol for TSH. Now that you know how the thyroid is regulated, let's take a look at what these thyroid hormones actually do. The most significant action of thyroid hormones is that they increase oxygen consumption in almost all tissues, minus the brain, gonads, and spleen. They do this by increasing the synthesis and activity of sodium-potassium ATPase, which you may remember is present in virtually all cells. This increase in oxygen consumption leads to an increase in the basal metabolic rate, BMR, and heat production, which is why this unfortunate patron is sweating excessively and trying to run away. Then again, bombs, ne'er-do-wells, jazz dancing, my hyperhidrosis would be acting up too. To help meet this increase in oxygen demand, thyroid hormones will also increase oxygen delivery by increasing the ventilation rate and increasing cardiac output. This is done by upregulating cardiac beta 1 receptors, which makes the heart more sensitive to sympathetic stimulation, leading to an increase in heart rate and contractility, and therefore cardiac output. This waiter is wearing a lung-shaped vest and spraying a large amount of water from his bottle to help remind you of this. Thyroid hormones will also increase overall metabolism through a variety of different processes. This is done to meet the increased demand for substrates that is created by the increased rate of oxygen consumption. This includes increasing glucose absorption from the GI tract, increasing glycogenolysis, gluconeogenesis and glucose oxidation, and increasing lipolysis. They will also increase both protein synthesis and degradation, although the overall effect is catabolic. Our waiter's tray of metabolic snacks includes glucose candy, bacon, and chewed up chicken wings to help you remember this. Thyroid hormones are also involved in promoting growth and are required for reaching adult stature, which is why this table has a large central bone-like leg. They do this by acting synergistically with growth hormone and insulin-like growth factors to stimulate bone formation. They are also involved in promoting bone maturation through the ossification and fusion of the growth plates. Last, but not least, thyroid hormones also play a vital role in the maturation of the central nervous system during the perinatal period, hence why this baby is in a brain bine. When there is a deficiency during the perinatal period, it results in irreversible intellectual disability, which is why neonatal screening for hypothyroidism is mandatory. Given thyroid hormones' profound effects, significant problems can occur when their regulation is impaired. For example, hypothyroidism occurs when there is a deficiency of thyroid hormones. This typically presents in adults as somnolence, a lack of energy, slow speech, and impaired memory, and is depicted here by this super sad guy with an untied bow tie. In contrast, hyperthyroidism occurs when there is an excess of thyroid hormones and usually presents in adults as hyperexcitability and irritability. If you take one last look at our sinister friend with the detonator, you'll see he is super excited and wearing a comically large bow tie to help show this. We cover both hypo and hyperthyroidism in more detail in a dedicated sketch, so be sure to check that out if you'd like to learn more. And that's it for this sketch. Well, almost. Before we let a lucky numbered Brit try to save the day, let's take a quick look back at what we've learned. The thyroid gland is made up of follicular cells, which produce the thyroid hormones, and parafollicular cells, or C cells, which produce calcitonin. On the back of the thyroid are 4 small parathyroid glands that produce parathyroid hormone, which is involved in regulating serum calcium and phosphate. The thyroid is controlled by the HPT axis. The hypothalamus releases TRH to stimulate the anterior pituitary to release TSH, which stimulates the thyroid to make and release T4, and to a lesser extent T3. T3 is 3 to 4 times more potent than T4 and is primarily produced in the peripheral tissues by converting T4 into T3. The HPT axis is regulated by a negative feedback system, where T3 and T4 inhibit TSH secretion from the anterior pituitary. This allows for a relatively steady rate of thyroid hormone secretion. The most significant action of thyroid hormones is that they increase oxygen consumption in almost all tissues, leading to an increase in the basal metabolic rate and heat production. They also help meet this increase in oxygen demand by increasing oxygen delivery. This is done by increasing the ventilation rate and cardiac output. They will also increase overall metabolism to meet the increased demand for substrates created by the increased oxygen consumption. This includes increasing glucose absorption in the GI tract, glycogenolysis, gluconeogenesis, lipolysis, and protein degradation. Thyroid hormones also act synergistically with growth hormone and IGFs to promote growth by stimulating bone formation and bone maturation. They are also necessary for the maturation of the central nervous system during the perinatal period. So much so that when they are deficient, it leads to irreversible intellectual disability. When there is a deficiency of thyroid hormones in the adult period, this results in hypothyroidism, which is characterized by somnolence, a lack of energy, slow speech, and impaired memory. In contrast, when there is an excess of thyroid hormones in the adult period, this results in hyperthyroidism, which is characterized by hyperexcitability and irritability. And that's it. Be sure to check out our next sketch if you want to learn more about hypo and hyperthyroidism. Now, If that countdown is anything to go by, I think I will skip the encore and call it a night. Later.